So as introduction to the day, I just want to go over some things, not offering any solutions, any resolutions, but kind of give some provocations, some thoughts, and I hope that other presenters will be addressing many of the issues mentioned here, okay? So the first thing when you, okay, oh, okay. So when you think about textbooks, people don't like them. And so these are Thomas Alva Edison. Edison, look what he said. Okay, so in a few years, motion pictures will basically replace textbooks. I mean, he should have probably start with building, light bulbs and stuff like that. Okay. Newt Gingrich, he was a politician under Bill Clinton. So again, no more textbooks. Okay. So in kind of preparing this, I looked at my university, and this is the earliest textbook I found on calculus, 1857. And just look at it. So there's lots of text, and the reader was actually invited or had to do their own illustrations to be able to follow the text. Okay. Now compare this to the present textbook. So I didn't want to identify the textbooks more or less because they're all the same, right? But see here, so you have two story problems. Picture is drawn, everything is labeled. So decisions about which variables should be involved, what's given, what I need to do, it's all already made for students. Okay, so the top is another example of something like that. Everything is given, everything is already labeled. So there's very little thinking that students have to do. So one thing actually we need to address today, and we will, is, so what's different? Not in terms of fonts or pictures or no pictures, but cognitively, right? So how does this change affect, and how will it affect if you continue changing the medium in which we present textbooks? Okay, so as you can see, there's emphasis on appearance. If you compare the two, shift from studying to reading, because there's almost nothing there left for you to understand. It's all given to you. Deeper challenging material is disappearing or is marginalized. So some time ago with a colleague, we figured out that if you do this, you open the doors for misconceptions. Because in mathematics, as you know, there are lots of subtleties, lots of things that you have to keep in mind, to make your own conclusions, to answer questions, things like that. And then our colleague, late Anna Sierpinska, she actually studied visual imagery, and she says that sometimes too much of it is counterproductive. Okay. Okay. I found another book. This is actually by our colleague, Isaac Newton. Translation into English is called Universal Arithmetic, where he talks about basically all math that he needs to do his research. Okay, next one. Okay. And then one thing that is relevant for this, at one point, so he does, by the way, he does very trivial algebra. He also talks about logarithms and stuff like that. And he says, after the learner has been sometime exercised in managing and transforming equations, so algebra, order requires that he should try his skill in bringing questions to an equation, AKA applications. Nothing new, right? Okay, so next slide, please. Okay, and here's an example where he has a story about merchants and some estate. And look how he does it. So there is English, and then teaches people how to translate into formulas and equations. Okay, next. Okay. So what I'm trying to say is that some ideas that we are looking for maybe are old ideas that need to be repackaged rather than trying to figure out something really, really new. Maybe something really, really new doesn't exist. Okay. Another issue, so where's textbooks in course design? These are kind of two extremes. And actually, I've done both in my life. So one idea on the left is you start with some vision of what you want to have in your course. You describe a curriculum. You design a course from blank slate. And as the last thing, you pick resources that match your ideas, your plans, learning objectives, things like that. The other thing that actually many of us do, and most of my colleagues at McMaster do, is they pick a resource first, and then that resource dictates curriculum, assessments, course designs, and everything else. Now, I'm not saying that one is good, the other one is bad, but of course, there are advantages and disadvantages. There are many advantages to the left approach. The problem is that in many cases, actually, you do not have an adequate resource, so you're forced to create your own. Well, how many of us do have time to actually do something like that? And especially if it happens, like it happens now at McMaster, that you might be teaching a course for 1 year and then somebody else is going to teach it next year. Okay. The approach where you pick resources first is kind of good exactly when you have this kind of change. So when lots of people teach a course, and they, unless there is a control, it could be a very different course given under the same name. So it's hard to compare. If somebody gets an A+ now compared to somebody who got A+ 2 years ago, well, is there a difference or not? Okay. Okay. So what are opportunities for alternatives to textbooks? One is to provide less control over the content. Okay, you can think how to possibly to do it, and variety. See, all calculus textbooks are about the same. Even if you look at table of contents, the way contents are organized, it's the same thing, right? So we don't have variety there at all. Okay, and also what is not in textbooks, I just listed a few things. So intuition, attempts at proofs, experimenting, trying various approaches. So what we call math habits of mind. So that's not in the textbooks. Opportunities, we talk about group work, but when you look at the textbook, it's more designed for individual learning. So that's another thing to think about, right? Okay. And also opportunities, what is missing for systematic individual practice. What I mean is, next slide, please. Okay. So for the course that actually my colleague Lee, who is here, and myself are teaching, we developed what is called drill sheets. It's also fancy word is deliberate practice, right? So you want to teach somebody the concept of a limit. You start with something very basic, and then every time you move to the next question, there is a very little change. So there's a small challenge that students have to overtake and then move on. And you make it in such a way that you're confident that students will be able to address these challenges. And then what happens? So questions 1 to 3. Question number 7 is the question. Next slide, please. Is that you would find it in textbooks, but you would not find what questions 1 to 6 in textbooks. Okay. And then you keep going and going, and then so there's lots of practice in between, and then you can prove some other limits. Okay. So in our estimate, it takes about 3 or 4 hours to do this, if you want to do the whole thing, but it's really worth it. Okay. Okay. Our textbook's expensive. On the left side, it's from McMaster Reddit. Somebody's inquiring about websites that have free textbooks. Okay. So on the right side is actually, it's a cabinet in front of our colleague's office at McMaster. One thing you notice on top of it, it's the newest edition of Stewart's Calculus. 7, 8 years ago, that book would have disappeared in 3 seconds. Somebody would have just taken it because they would need it. Now it just stands there and nobody is actually touching it. But we'll see why. Okay, next. Okay. Okay, so when students say that textbooks should be free, you should look at this, okay? So what is the price of materials within the whole entirety of spending in university? As you can see, it's about the same as alcohol, okay? But then students will say, we need alcohol to socialize. Okay, fine, but you know, you need textbooks to learn, right? Okay. So this is one thing. But also one thing you can do, and I do it in my Numbers for Life course. If you just reduce the rent by 5% and tuition by 5%, it offsets total cost of your textbooks, right? But then are you going to approach your landlord and ask for 5% decrease? No, but you're going to yell at publishers for being expensive, right? Okay, next one. Okay, so here are the prices because we use Stewart's Calculus. Well, new paper textbook is about, say, $175, $180, okay? Used is about 25% cheaper, okay? And now here's one thing. As a student, you can say $180 is a lot. But you use it for 2 courses, and you can sell it as a used book. If you do that, say, suppose you sell it for $100 as a used book, you're basically paying $40 per semester for a textbook, which isn't that much, right? Okay, so I want to present results of a survey in 2 different courses we did. So one is, again, my colleague Lee is teaching it. It's math, which we call service course for econ and business, and then a survey that I did for math and stats majors. Okay, yeah, next one. Okay, so how did you get hold of your textbook? Look at this. So the green thing is that I'm using a free PDF textbook that I found on the internet or obtained a copy from someone. So people have friends and they're really good friends and they find free PDFs, right? Okay. So in this case, about 35% of people did not pay for a textbook, and 41%, 42% bought an electronic version. Now, next one, please. If you look at Stuart, it's much worse than that. So about 74% are using free PDF. And by the way, students are not ashamed to admit that. I ask them in my office hour, right? Because they all have PDFs, right? Okay. So now our textbook is expensive. As a matter of fact, in my opinion, prices of materials that students buy are actually going down. And they're not increasing, they're decreasing. Okay. So just a few other things about the surveys. So how do you use Stuart's textbook? So how do math and stats people use a textbook? And as you can see, it's very creative. So they're using it in ways that actually we would want them to use. So sometimes I study a section or part of a section, well, 57% say that, right? And of course, the biggest part is to use as a source of practice questions. Okay, next one. Okay, and it's even more pronounced in service math course. So it's less of those good things that we want students to use and more as a source of practice problems. Okay. Next one, so we also asked, besides textbook, in this case, Stuart, and you'll see the other one. So what other materials do you use? And you can see, so the biggest bars are videos on YouTube, AI resources such as ChatGPT, math software such as Desmos, and mother-in-law. One person uses their mother-in-law. So humans, right? Okay. And you'll see in the other course, yes, go ahead. It's even more pronounced. So YouTube, ChatGPT, things like Desmos, right? These are major alternative to textbooks, and somebody's grandmother as well at the bottom. Okay. Assume that the paper textbook and its electronic version are identical in content, cost the same. If you decide to buy one, which one would you buy? As you can see, it's not all electronic, right? There's still a good number of people who would prefer to, buy a paper textbook. Okay, next one. When we ask them, how do you take notes in class? As you can see, it's, again, 41, 42% still use paper. You kind of see lots of iPads in class, but obviously lots of people still use paper, right? That's again, something to think about. Okay. Now, we started a little late, so I have a few more slides, but I'm going to stop with this one, and I'm confident that whatever I missed will be addressed in other people's talks anyway. So if you apply technology, say from long ago, when we went from oral culture to written culture, that was a huge shift in technology, right? So when we went from memorizing to writing things down, that was a huge shift. Now we have similar shifts as well, right? So if you apply technology to knowledge, how do you reshape that knowledge? Is that reshaping actually desirable? Is that what you want, your students to have? Is it how they're going to learn? And what happens if some of the stuff doesn't fit? Okay, so especially people who are into electronic things and open resources might actually want to address this issue. Okay. Okay, for instance, one small thing, benefits of drawing something in hand versus using software to draw the same thing, right? Think about it. So there are different cognitive processes that are involved. Okay, so thank you. So now we'll invite Francina to introduce our next speakers.